Hello and welcome to another episode of TWiML Talk, the podcast where I interview interesting people doing interesting things in machine learning and artificial intelligence. I'm your host, Sam Charrington. This week's shows are drawn from some of the great conversations I had at the recent NVIDIA GPU Technology Conference, and they're brought to you by Dell. If you caught my tweets from GTC, you may already know that one of the announcements this year was a new reference architecture for data science workstations powered by high-end GPUs and accelerated software such as NVIDIA's Rapids. Dell was among the key partners showcased during the launch and offers a line of workstations designed for modern machine learning and AI workloads. To learn more about Dell Precision Workstations and some of the ways they're being used by customers in industries like media and entertainment, engineering and manufacturing, healthcare and life sciences, oil and gas, and financial services, visit dellemc.com/precision. All right, everyone, I am on the line with Trista Chen. Trista is the Chief Scientist of Machine Learning at Inventec. Trista, welcome to This Week in Machine Learning and AI.
Thank you, Sam. Thank you for inviting me.
Absolutely. I'm looking forward to our conversation. Before we jump into the heart of our talk, which will be focused on a presentation you did recently at the NVIDIA GTC conference on Edge AI and smart manufacturing, I'd love to learn a bit about your background. How did you get started working in machine learning?
I'm always a visual person to start with as a child. So naturally, I studied computer vision. And after finishing my PhD at Carnegie Mellon University, I joined NVIDIA to be the first video architect of their video processor. So video processor is their new line of processor in addition to the graphic processor, so that they can handle all the video encoding, decoding, and pre-processing, post-processing more smoothly. After NVIDIA, I joined Intel to be their research scientist. I lead a team of researchers in Russia to do OpenCV development, as well as working on many-core and multi-core processor research. So OpenCV, to some of you who know the open source library, is probably the biggest open source library on computer vision. It have 14 million downloads so far, and I'm very happy to be part of the effort to contribute to the community to help everybody to have a quick head start in all the computer vision applications. And after Intel, I think most people at Silicon Valley had this dream of starting their own company. So I started my own company doing computer vision for other companies. So basically a B2B effort. So I help company to annotate their image or video assets so that they can match related advertisement to their image or video. So example to that would be if you watch a YouTube video, right? So a lot of them are consumer generated, and you want to monetize them. So our company will help them to look at what's inside the video, and then what would be the appropriate related content. For example, if you have posted a video about riding a bicycle in the wild, then maybe we will match a REI advertisement for you. And same thing with image. So if you write a blog about your dinner with friends, and then you write a blog about going to somewhere for fun, then we can match that with travel advertisement and whatnot. And so we got accepted by Y Combinator in their last round, but eventually I didn't join the Y Combinator effort. And then because I was a first-time entrepreneur, it wasn't successful. And after that, I get a taste of a startup, and I decided to join another startup, which was called Cognitive Networks. So what they do is they do content recognition on TV. So they had this small device inside the TV that they partner with, so that they can understand exactly what TV content you are watching. For example, you are watching Big Bang Theory, episode 8 and to the minute of 2 and 30 seconds and whatnot.
Mm-hmm.
So by knowing what you are watching at the moment, they can do a lot of analytics on the video. They can know the advertisement or the campaign effectiveness and whatnot. So eventually, the company was successful and got acquired by Vizio, one of the top TV manufacturer in the world. And so after the happy acquisition, I kind of semi-retire per se. After like 15 years of Silicon Valley, like hard working and craziness. So I actually moved across Pacific Ocean to Taiwan. Actually my career has been interesting in that it spanned different countries, it spanned different areas, also from research to industry research, from big companies and eventually startup. And now I'm moving back to another big company, which is Inventec in Taiwan. So for a lot of you in US, you might not be aware of the company Inventec. It's actually a OEM, or some of you might have heard of Foxconn, right? So Foxconn manufacture all the Apple devices for Apple. So Inventec is a similar line of company. So they manufacture cloud servers, laptops, and smart devices for all the famous computers you ever heard of, even though you never heard of Inventec itself because it's an OEM. As a chief scientist in the company, I'm helping the company to optimize their industrial 4.0 effort in the factory, as well as looking at future direction in products so that we can prepare ourselves to be ready to manufacture new line of AI products for our customers.
And so the presentation that you did at GTC around the application of AI at the edge, was that for Inventec's own manufacturing facilities or for customers or partners?
Yeah, the answer is yes and no. So to start the research, we actually focus mostly internally. So we go to the factory and talk to the people in the production line to understand what their needs and what their pain point is. And from there, we develop the solutions. So what you see in our GTC presentation are the real application that we develop for the factories. And from there, it becomes a solution. So it's possible that we provide the solution or we customize a solution for other customers other than Inventec. But that's another process. So now we are not talking about that in the presentation. So the presentation that you saw is for Inventec only.
Okay, great. And so we're not going to assume that anyone listening has seen the presentation. So why don't you walk us through the main points of the case study? What were the main challenges that you were trying to solve? Let's start there.
Okay. So manufacturing is actually a very interesting area. So most people, they hold their smartphones, they had their computers, but they had no knowledge about those factories. So they imagine something like, oh, there's this big, huge factory in China somewhere, and there's some like huge robots or many robots working there, along with maybe a lot of cheap laborers and all that. Honestly, it's more advanced than that. So Industry 4.0 is actually an effort to digitize a lot of the physical part of the factory so that we can seamlessly integrate what we sense from the physical, for example, the defects or what we see from the production line together with a lot of the knowledge that we learned from previously for that to optimize the process. Okay, so let me give you an example. So traditionally in like Industrial 3.0, So we will need a lot of humans to look at, for example, the PCB board or the motherboard of a computer one by one, right? To make sure that the components in the PCB board are not misplaced, they are not having any defects, they are not missing, and whatnot. But then you can imagine that it's pretty cost ineffective, right? And then human can get tired and they can get inconsistent in their result. So by using computer vision to do this, we can ensure that the accuracy of the detection is much higher. And more importantly, you'll be more consistent, right? So a lot of people or a lot of labor before lunchtime, they get so tired, they want to go to lunch, and they will simply just press OK or pass to the product, right? And then they just go to, and then they finish their job and they can go, right? But then for computer, they won't have such a problem. They'll just keep working tirelessly. So this is the very obvious example of application of AI in manufacturing. But honestly, industry application of AI is actually a very broad area. So according to McKinsey, a report of McKinsey in 2013, there are actually more manufacturing data than any other sector combined, okay, in a year. So that would be 2 exabytes, so 2 and then 10 to the power of 18 bytes of data per year, according to the report. And that amount of data can be used to do a lot of interesting things. In addition to defect detection, so it could be used to do predictive maintenance. It can be used to do operational optimization, supply chain optimization, and all that. So what we talk about in GTC is just a very small portion of how AI can help manufacturing or factory.
Now, one of the things that I've heard in talking to folks about this space, and I'm curious if you've seen similar, is that, one of the big challenges here is that, while there is a ton of data, often it's locked in proprietary systems. Like a robotics provider might provide the robot, but not open up the data to the customer to integrate it in with other things, or they may have data in some SCADA system, but there aren't easy interfaces to accessing or using that data. Do you find that in your world as well?
Yeah, that's an excellent question, actually. So there are two aspects to that. So one is the device. Would the device actually output the data you need in order to do your AI thing? So for example, in the case of defect detection, right? So AOI machine stands for automatic optical inspection. So what they do is they use a camera plus some algorithm to detect defect. But a lot of time, those AOI vendor, they won't output the raw image to the factory people. So what they gonna output is just a result of pass or fail of this PCB board. And there's a good reason that they don't want to release that precious data to the customer. So oftentimes you have to pay extra fee or maintenance fee or service fee in order to get those data to do further optimization as a factory customer to those device manufacturer. So that's one aspect to that. And the other aspect is even the factory have access to all this confidential or secret data. It's usually hard or impossible for the outsider to touch those sensitive manufacturing data to do further things. So I will use an example, right? For example, like Landing AI. So a company that is started by Andrew Yang, one of the AI pioneer, right? So Landing AI, they claim to work on this field of industrial AI. But honestly, any outsider is close to impossible to touch data like what is the yield rate of the process, and then, for example, what is the inventory level, and what is the order level, or the order number, the sales order number of this factory or for this site. So those are so sensitive that it's impossible to release to outsiders. So to answer your question, I think a lot of the thing is happening inside the factory, inside the wall of the factory. So the wall could be physical, it could be digital, but whichever, everything is contained. So it's not as, I would say it's not a sexy field to work with by design, so that they can keep all the secret data that can affect their like stock price, and then that can affect a lot of like things, transactions. They keep everything inside and then work on those data inside the wall.
And so you mentioned these AOI systems. When folks are deploying AI to do visual inspection, that's one of the big use case areas for AI in the industrial context is defect reduction and visual inspection. Is the goal to replace the existing AOI systems, which tend to be based on more traditional computer vision algorithms as opposed to machine learning? Or is it to, as you're suggesting, take their data and optimize but still use those systems? And there are lots of different types of computer vision based systems on the in a manufacturing environment. There are these defect detection systems. There are the sorting types of systems, but they're all kind of characterized as being these closed systems where you'd want to have the data to optimize. Are folks trying to replace these with more open types of systems, or just get access to the data and feed it back to what those systems are doing?
Yeah, I think it depends on the stage of your development in using AI in factory. So AOI is actually a pretty mature field. So you can go out and talk to at least 100 different AOI vendors in the market and buy machines that do AOI for you. So like you said, so currently most of the AOI machine in the market, they're using the so-called traditional computer vision methods to find out the defects. For example, it can detect the lines, it can detect a pattern, and then the AOI machine will realize that this pattern is like 10 degrees different from the position or the angle that it should be, right? Or the part is missing because the pattern doesn't match. So those are a pretty typical computer vision thing that, for example, OpenCV can do. But for some of the defects, like solder, that is kind of fuzzy or ambiguous. Human can do pretty good on that. They can look at the image and say, hey, this is too much solder and this is like too little solder. But for computer or for traditional computer vision, what they see is just a bunch of stuff, right? They don't know the angle. It's probably hard for them to calculate the area. And that would be the thing that is most suitable for the deep learning based AI algorithm to attack or to solve. Mm-hmm. And so like you said, right? So AOI machine, if it's capable, if you can get the image out of the machine, then you can have a second stage reinspection engine to the image so that you can fix the defect detection after you have fixed already the first level of defect detection. The first level will be the easier cases that you can detect with traditional computer vision, and in the second stage, you can use AI-based method to solve the harder to detect kind of fuzzy, ambiguous case. And eventually, if the system is smart enough, and maybe eventually some of the AI machine is smart enough, it can combine both of the traditional and the new deep learning based method together. So you can either switch in between or fuse them together, so that you will have one like super powerful AI machine that does everything and that can look at different kind of defects that have different characteristics. So the way I see that is like there's no one answer to that. It depends on the stage of your development, and sometimes it's 2 stages, sometimes it's like one big stage and that.
So we've talked about AOI and defect detection quite a bit. Were there other use cases that you mentioned in your presentation?
Yes. So this presentation is mostly focused on defect detection, even though I talked earlier, like there's other application of AI in factory, for example, like order prediction, like predictive maintenance, like safety improvement using computer vision or environmental aspect of the AI. So there are actually a lot of more different applications, but it's not mentioned in my presentation.
Just based on the title of your presentation, you also were incorporating the idea of edge into
Right.
it. Where does that fit in?
So there are two kind of scenarios. One is edge. The other one is cloud. So cloud in general is the mainstream of most of the AI application right now. So in terms of image, you capture image or video, you send that to the cloud, and the cloud had usually super powerful machine with graphic processing there, and they do all the inference, and they spit out some results. For example, pass or fail, or they tell you the object type that's contained in this image, and that's then send it back to the user, which is at the edge. So that's one scenario. The other scenario is edge, meaning you don't send your image or your data to the cloud. You compute everything on site. And when I say on site, there are a few benefits to that. So one obvious benefit is privacy. So there's no intermediate point that you can hijack the data. You can keep everything within the locality of this edge device. So privacy is number one. And number two is reliability. So reliability, what I mean by that is sometimes the network or the communication become unreliable. It can drop off, or the bandwidth can be reduced, and there could be error in your transmission. And as I said earlier, there could be interference, or somebody can hijack your data or your package. And that causes a huge issue in the result, right? So by having edge AI, then you avoid that problem. And the last point of edge AI, the benefit would be network efficiency. So in terms of defect detection, so image data is input for your AI engine, and image data are usually quite big, especially if you had like hundreds, thousands, if not millions of images sent in to the cloud every hour, right? That would pretty much jam all your infrastructure, the network infrastructure. So by computing on the edge, then you avoid that problem altogether. So you don't have that problem.
And so most of the conversation around edge today is focused on edge inference, and we're seeing a lot of new hardware. Actually, almost every week there's folks proposing new hardware approaches for edge-based inference, low-power inference, etc. But there's also work happening around more advanced scenarios that we're just starting to see, like federated learning and ways to combine the edge with the cloud and to have learning that incorporates the edge. Are you doing any work in that area or seeing anything interesting in some of these more advanced scenarios?
Yes. So what you just mentioned, I believe, is something called hybrid AI. Basically, AI computation or inference can happen, like I said, in both cloud and edge. An edge device traditionally are pretty, they don't have that much power. So they can at most, in the case of image, they can at most capture image, and at most extract some features like edge, like region of interest, and send the data back to the cloud to do most of the computation, like detection and classification and all that. But nowadays, more and more AI device at the edge, like you said, is like popping up from the market pretty much every day. I think in addition to those AI chips per se, a lot of existing devices like cameras, they start to have more and more like teraflops inside their module already. So I think it's right now it's kind of like a messy situation that everybody is trying to capture some piece of this AI chip or edge AI market. So what I observe right now may not be conclusive, but I think this trend is gonna continue, and then everybody is gonna expand their territory. So Amazon is gonna claim that cloud service it's more powerful, more accurate, and then it's easier to deploy and all that. And then I think the edge AI people or the chip people, they're gonna say, hey, it's more private, it's more reliable and whatnot. I think this war is gonna continue, and then eventually nobody's gonna win or lose. I think it's gonna be win-win, and then is depending on your usage scenario, and then you will choose the best solution, I'm sure.
Going back to this idea of hybrid AI, have you seen any use cases for doing some learning at the edge and some learning in the cloud?
So in particular to learning, so most of the edge devices right now, they only do inference. So they don't have the capability of adapting or training on the go. So what usually happens is you download a model. So they call it model, a deep learning model from the cloud. So those are trained in the cloud. And in the edge, they simply do the inference or testing. So in the case of human detection, and they at the edge they deploy like say smart camera with an AI chip inside. For example, the smart camera will do the detection and happy, right? But if somehow the population that this camera see start to change or migrate over time, so you might need to update your model about how people around this area look like, right? So in this case, you will have to update your model. And currently, all the training is still in the cloud, and the updating of the model is still happening in the cloud. And you still have to periodically, or depends on the event that you download the new model, updating model to the edge device. So there's no on-device training currently, as far as I can see. So the hybrid AI that I see is mostly training in the cloud, inference in the edge.
Yeah, that's a little bit different from this thing that is, still a bit undefined and maybe even still a bit mythical of federated AI, where you're trying to do distributed training across multiple devices. But I keep asking everyone who might know a little bit about, might have seen it to get a sense for if anyone's doing it out in the wild yet.
Yeah, so in terms of distributed AI in training, I do see quite a few applications in there. So coming back to the example of human recognition. So for example, you can place your camera in different locations, different cities, and different city will have different people looking differently, right? In New York, you have people look like they dress in suits and like very serious. They look serious, right? So and then you have some camera that's in suburban area that people dress like t-shirt and sandals and whatnot. So collection of data, they happen distributively. That's obvious, right? Mm-hmm. And in terms of training, I think distributed training, they might have a local training server that is in the proximity of those sensors and do the local training on how the human look like in that area. And eventually they will combine the model in the cloud so that you would have this like very smart algorithm that can understand how human look like in different areas. So that's what I see in distributed AI training, but I don't see distributed AI inference because there's no such need to do inference in multiple locations as far as I see, because inference usually is not as heavy as training. So you don't need distributed inference.
And so this distributed training that you're referring to, when the model is combined, is that fairly simple combination, like some kind of ensembling, or where you're running multiple models and picking the one that's most confident? Or is it something more elaborate where you're kind of merging the models in some kind of way?
Yeah, that's there are different level of integration or different level of merging of the model. So the simplest way is like winner take all, right? So which model performs the best in that case then wins, right? So the other case is simple weighting. So you weigh the score from different model in different locations and combine the result. So that's a second approach. Still pretty simple. And eventually you can go to this like super complicated case that you have another neural network right? That neural network is trying to combine all this like child model and combine it together. And in that, you will need training data from more training data so that you can train the parameter or hyperparameters of this super neural network on top of all these child models. So there are different complexity in terms of how you combine it together.
Going back to your presentation, one of the things that you mentioned is the need to redefine the problems in order to get the kind of results in terms of ROI and solution capability that you're ultimately looking for. Can you elaborate a bit on that and how that comes up?
Yeah. So when we start talking to the factory people, right? They are hardworking people. They focus on one specific area every single day. So one of them talked to us about the problem that they are facing. They're like, "Oh, our inventory is so big that we have to keep building a warehouse to store all the parts that we need. And then the warehouse is getting bigger and bigger. It's getting harder and harder to manage." And then so they're like, "Oh, can AI help us to manage the inventory and also to help us to build a bigger warehouse?" And we're like, that's an interesting question to have. Let's figure out like how we do that. But we are not architects. We don't build warehouses. So how can we help them? So after digging deeper and talk to them more, they actually had different problems that caused this warehouse problem, right? So what they have is they actually don't have accurate forecast or accurate prediction of their order. So that in order to meet or in order to fulfill the requirement of the customer, they have to prepare a lot of parts in advance so that if the customer wants something, they can quickly pull out the parts and assemble the computer for the customer. So eventually, this is not a warehouse problem or how to manage a warehouse problem. This is actually a order prediction problem. So this is what I mean by one of the key example of redefine the problem and using AI. And another thing that you mentioned is this ROI thing. So ROI stands for return on investment. So this is a typical practice of everybody working in manufacturing or industry. So in order to buy something or in order to adopt a solution, you have to actually calculate. So this much cost will take you 2 years, 3 years, 18 months, whatever long time that to recapture the cost that you invest, right? And so for a lot of the things, ROI is really hard to calculate because this is not a typical stationary or static optimization problem that you have all the parameters laying out in front of you, and then you can do your optimization and do your trick, and then you come out with some like savings or you come up with some improvement. This is actually a dynamic process, right? So when you are optimizing the system, you're actually changing the nature of the factory. And it's similar to stock market, right? So you don't, it's like Warren Buffett, like playing in the stock market. When he decided to buy something, actually he changed the S&P index already because the volume is so big. So similar to that. So when you actually change something or invest, put something into the factory, you actually change the nature of the problem. So it's a on the go target. So ROI is consequently very difficult to calculate.
Can you give a specific example of a change that AI causes in the factory that makes it difficult to estimate ROI? And one point of clarification before you do that, is the challenge specifically with forecasting ROI or measuring it after the fact, or both?
I think it's both. So forecasting is actually harder. So let's say I decide to buy robots. Okay, I decide to buy a robot to move all the parts in different size of my factory, and then you can say, hey, the robot cost me like $1 million and blah blah blah, and then so the ROI is like 18 months, right? But then this is actually eventually is going to be wrong. Reason for that is by adopting robot, you actually improve the accuracy of or the time that arrive at different manufacturing lines. So the time they arrive at the line is more precise. So you can produce your product in a more timely manner. So your yield rate will be higher and all that. So when your yield rate is higher, actually the overall profit or revenue of the company is increased. And how do you factor that into your calculation of ROI, right? And that's why in prediction or in measuring both, the ROI calculation is often wrong.
Okay. It sounds like, if I could maybe try to restate that, it sounds like when you automate in the manufacturing facility, there's a specific thing that you're trying to improve. Maybe it's reducing defect and then you automate, but the introduction of automation has a bunch of downstream effects like increasing consistency and reducing wait times and things like that. And it's hard to produce an all-encompassing ROI study that takes into account all these different factors. Trista, were there any other thoughts that you included in your presentation as key takeaways, or any parting thoughts that you'd like to leave with the audience that might help them in their path towards Industry 4.0?
Yes, so Industry 4.0 is a seamless integration of physical and digital world. So the obvious benefit will be accuracy, consistency, and ROI. And then what I want to stress is actually go higher than that. So if you can actually get all those digital and physical data, IoT data with you, you can do much, much more optimization. You can actually change the whole scope of how you design the manufacturing line. You can change how you take the order. You can change how you ship. You can change the location where you stock your inventory. You can change the whole thing. I think without the digital and physical integration, or people call it digital twin, without that, there's no way you can do such a ground up change of the whole manufacturing process. So in addition to focus on the obvious benefit, I think everybody working in manufacturing should look one step up and looking at what you can do to change the whole process. And then the gain is not just 10%, 20%. It could be like exponential, like 2 times, and can be 10 times, because the whole thing is changed.
Awesome. Well, Trista, thank you so much for chatting with us.
Thank you.
All right, everyone, that's our show for today. For more information on any of the shows in our GTC 2019 series, visit twimlai.com/GTC19. Thanks again to Dell for sponsoring this series. Be sure to check them out at dellemc.com/precision. As always, thanks so much for listening, and catch you next time.